We obviously hear a lot about how much methane gets emitted by livestock, so I thought I'll put a few figures from FAO just to show some numbers. Obviously, we have mentioned before, I think, where cattle, cows, ruminants have evolved to digest things in an incredibly thermodynamically inefficient way. They gobble up everything. They have a sense of smell which tells them this is food or this is not food, and they have a keen sense of smell. And apparently cattle have an additional sensory olfactory sensor top of the mouth called Jacob's organ or something, and you can often see them opening their mouth and smelling things. And as I mentioned before, in India they eat all kinds of garbage like plastic and cardboard and God knows what else, and they store it, and then they when they are resting they belch it back out and ruminate on them. So obviously the enteric fermentation is still converting sugars to carbohydrates, but also volatile fatty acids, carbon dioxide and methane, and they are belching out a lot of the methane and CO2 from both ends. And they also produce solid waste, and which also can be a source of methane. Plus the operations of livestock industrial production themselves have lots of environmental issues, or footprints, let's say, not issues, because we all consume meat, I suppose, or dairy, which makes us part of the problem as well, or can be part of the solution if we want to solve it. So livestock production by region in million tons of protein is shown here. So you can see US, so these are basically from beef, cattle milk, pork, chicken meat and eggs, small ruminants for meat and milk, and buffalo for meat and milk. And you can see a country like India has lots of buffalo and lots of chicken, and a fair number of cattle for milk as well. Okay, so you see the distribution here. Obviously East and Southeast Asia dominates in terms of their consumption of chicken and pork, and they have a fair number of cattle milk and beef as well. India tends to be small on the beef market, but it exports a lot of beef, so it doesn't necessarily consume as much, but especially buffalo meat, it exports a lot. I think, I don't have the numbers, but nonetheless there are other countries. South America is big on meat and dairy, and so is Europe. Russian Federation here is small, and Eastern Europe is small. Africa is relatively small as well. Okay, just relatively speaking, just now, for example, US put out the plan for climate action, and people said beef is not on the list of things to remove, but already there is a lot of propaganda about how Biden wants to remove meat from your plate and so on and so forth. Many articles have been written about just how bad per calorie beef is for the environment, for consumption of grains and primary production and so on and so forth. So looking at million tons CO2 equivalent, beef is way up there at more than 5,000. Next come in the pigs, drops by an order of magnitude, chicken, buffalo, small ruminants and other poultry like geese, ducks, whatever else lots of countries consume. Okay, so obviously shifting dietary preferences, maybe by lab produced meats which are being experimented more and more, can be a solution. Just looking at the contributions, the enteric fermentation is 44% of the total emissions, whereas manure management, energy consumption for the operations, and feed that's used to grow beef contribute significant rest of the amounts for methane. And if you look at the supply chain, you have here again, zooming out, enteric fermentation, manure management, N2O and methane. farm gate CO2 direct energy use, indirect energy use, and in the feed operations in industrial cattle growing, it can be quite large. So you have applied and deposited manure and N2O emissions, CO2 emissions, in fertilizers and crop residues, again N2O production, and you have pasture expansions, land use change contributions in terms of soy and palm conversions, and feed in terms of rice residues and direct rice and so on in terms of methane. Okay, so obviously cattle are significant contributors, and here is million tons of CO2 equivalent by region. Again, same beef, cattle, pork, chicken, and so on. And you can see that South America here dominates in terms of beef production, massive consumption as well as export. India is quite large, South Asia in general, including the neighborhood, and East and South Asia. So when you look at production versus emissions, you have to be aware of the subtle differences in terms of how the supply chain and production is affected overall for CO2 equivalent emissions. The other natural emissions are of course coming from wetlands, which are big carbon sequestration spots. Wetlands are basically where groundwater is always visible, and there is vegetation and carbon sequestration. Because it's underwater, it's not respired as easily because of lack of oxygen and so on, but obviously they produce methane. And you can see that tropics and extratropics all the way to high latitudes have types of wetlands, which there are classifications, and there are also methane hydrates, which is where the methane produced by anaerobic respiration under pressure forms a kind of crystal with water. So you can see that they are both frozen, so water molecules and methane gas molecules. There is no reaction between them, so only thing holding the methane down is this ice, and obviously this is very vulnerable to fast release. So this is how it would burn. If you bring it out to normal levels of oxygen, it's just going to burn, because that's how highly concentrated methane there is in it. And why would we worry about it? Because if you look at the amount of carbon in gigatons buried in hydrates compared to gas, oil and coal, it's much more massive. So we talked about this in the Paleocene-Eocene thermal maximum, which I'll come back to, but obviously hydrates are something to worry about. So we will look at whether there is a chance for hydrates to be released and have a huge slug of carbon to be released into the atmosphere to give us this kind of rapid warming that was seen in Paleocene-Eocene thermal maximum. Okay.